Now, we are going to study graphical and tabular descriptive technique. We are going to study types of data first, then graphical and tabular technique for nominal data. I'm going to explain what is nominal data, then graphical technique for interval data and archive. First, let's see definition of a variable. Variable is some characteristic of a population or sample. Example is student grade. Variable is typically denoted with a capital letter XYZ, capital letter XYZ. And the value of variable are the range of possible value for variable. Value of a variable is a range of possible value. So student mark 0, 10, 80, these are the values of a variable. Data are the observed value of variable. So these are student mark. Okay. So variable is denoted by this, and data is observed value of a variable. So you should know what is the definition of a variable and observed value. And these are the types of data. As you can see, data fall into three main groups: interval data, nominal data, and ordinal data. You should know what is the definition of interval data, nominal data, and ordinal data. Okay. In our class, we generally use interval data a lot. Okay. But you should know what the definition of nominal data, ordinal data. First, interval data. Interval data is a real number. For example, heights, weights, price, etc. all are what? Interval data. Interval data also referred to as a quantitative numerical data. So if you heard here what quantitative or numerical data, it's interval data. In interval data, arithmetic operations can be performed. Okay, plus, minus, times, division, all possible. Okay, arithmetic operation can be performed on interval data. Thus, it's meaningful to talk about 2 times height or price plus $1 and so on. Okay, that's interval data. You guys understand? Now, let's look at the nominal data. The values of nominal data are calories. So, the example of nominal data responds to question about marital status. If you get this response, then you can code in your compute as single is 1, married is 2, divorced is 3, widow is 4. This is example, okay? And these are calorie, okay? All these are calorie. So these data are categorical in nature, okay? So if you see calorie or categorical, then these are nominal data. In nominal data, arithmetic operation don't make any sense. For example, widow divided by 2 is married. Is it meaningful? No. Oh, no. So in nominal data, arithmetic operation don't make any sense. Nominal data are also called qualitative categorical. First we run interval data. Interval data is quantitative. But nominal data, second we run the nominal data, it is a qualitative and categorical. Final data types are ordinal data. ordinal data appear to be categorical in nature, but their value have an order or ranking to them. What ordinal data? Categorical in nature, but their value have an order, ranking to them. Example is here, college course rating system. Poor, fair, good, very good, excellent, 1, 2, 3, 4, 5. You can see these are what? Categorical, right? But they have odd ranking, okay? While it is still not meaningful to the arithmetic on this data, we can say things like excellent is better than poor, fair is less than very good, okay? That's order is maintained. Order is maintained no matter what numerical value are assigned to each category. This is ordinal data, okay? Are you following me? So let's see calculation for types of data. As mentioned above, all calculations are permitted on interval data. Okay, all calculations are permitted on interval data. Only calculation involving ranking process allow for ordinal data. No calculations are allowed for nominal data. But in here, nominal data, counting the number of observations in each category. So this lends itself to the following hierarchy of the data. Okay, based on this calculation for types of data, we will see hierarchy of data next slide. As you can see, this is a hierarchy of data. Interval, ordinal, nominal. Okay. In interval data, value are real number. Okay. All calculations are valid. Data may be treated as ordinal or nominal. As you can see, interval data treated as ordinal or nominal. Okay. Based on calculation. Okay. Based on calculation. Ordinal data value must represent ranked order of data, ranked order of data. Calculation based on ordering process are valid. Data may be treated as a nominal but not as interval. Nominal data value are arbitrary number that represent the category. Arbitrary number that represent the category. Only calculation based on frequency of occurrence are valid. Frequency. Okay. Data may not be treated as ordinal or interval. That's what hierarchy of data. Interval, ordinal, nominal. Graphical and tabular technique for nominal data. So here we are going to dealing with the nominal data. Nominal data. The only allowable calculation on nominal data is count the frequency. Okay, count the frequency over each of the variable. We can summarize data in a table that present category, okay, and the count called the frequency distribution. So here in the example, we are going to create a frequency distribution. Frequency distribution summarize data in a table that present the category and the count. And also we are going to create relative frequency distribution. Relative frequency distribution lists the category and the proportion with each occurs. Okay, so we are going to create frequency, and that is called the relative frequency distribution. So now we are going to create frequency distribution and relative frequency distribution. It is for graphical technique for nominal data. But before we create graph, we will create a table first. Let's see this example. Right via preference survey. Are you ready? Right via preference survey. In a certain year, total right via sales in a country was approximately 3 million gallons. With this large market brewery often need to know more about who is buying their product. The marketing manager of a major brewery wanted to analyze, that's their goal, analyze rye beer sales among college and university students who do drink rye beer. Random sample of 200 graduating students. So it's what? Sample, right? Sample. Population is what? A lot. Population is a lot, but we just sample is 285 graduating students was asked to report which of the following is their favorite rye beer. That's they will get the sample from 285 graduate students, but they are going to infer, based on this, they are going to infer the population information. These are their selection, okay, their choice. If they choose one, Budweiser right, second, Bush right, third, Coors right, fourth, Michelob, Miller, Natural, other. Response was recorded using the codes. So if they choose not the Budweiser, it's 1, 2, 3, 4 are recorded. Constructor, as I told you, we are going to create frequency distribution. Next one, relative frequency distribution. Okay, we are going to construct frequency distribution, relative frequency distribution for this data, and graphically summarize data by producing bar chart and pie chart. As you can see, this is the data result. Okay, result from previous survey. Okay, this is data set. As you can see, if you see this number, we cannot get much information here. However, for this data, we use a descriptive statistic to get the useful information. That's one of the definition of statistic, explanation of the statistic. Okay, see previous explanation about statistic. What is the other explanation of statistic or definition? See, now it's right time to check previous lecture. Okay, as I told you, for this reality, you can see this is reality. Okay, for this reality, you will use statistics way of thinking to interpret reality. Okay. So now, based on previous data, we can create this frequency distribution and this relative frequency distribution. Okay, this is a table technique for nominal data, and previous one is nominal data. For that nominal data, we can create this frequency distribution, a relative frequency distribution. If you use count if function in the Excel, we can create easily, but now we are not going to exercise that one. When we meet offline, we will create, we will exercise frequency distribution and relative frequency distribution. But now just try to understand what is the meaning of that. Okay, for board right, 90 student select, Bush right, 19. Coors 62, blah blah blah, and total number is 285 sample. Okay, so this number is, how do you get this number? 90 divided by 285. Relative frequency 19 divided by 285. Then you can see this relative frequency. You know how to get this, right? Then let's interpret this one. Okay, based on previous frequency distribution, now we can create this bar chart. Okay, and this is bar chart. So easy to interpret previous data, right? from based on a table, we can create a chart. Okay, so bar charts are often used to display frequency. Okay, you see this kind of chart in the newspaper a lot, right? So it's easy to see which one is best, which one is last. Okay, number 1 is 19, number 4 is 13. Okay, but these are the category, right? Previous one, category. Or you can see from the relative frequency distribution, we can create a pie chart. Bar chart from frequency distribution, pie chart from relative frequency distribution. So pie chart show relative frequency like this. Okay. Number 1 is 31%, number 2 is 7%, number 3 is 22%, like this. And these are all of them. Frequency distribution, relative frequency distribution. From relative frequency distribution, we create a bar chart. And relative frequency distribution, we create a pie chart. Same information, but different presentation. Okay. So what? As you can see, with the raw data, we cannot get much information, but using descriptive statistic technique, we can create this one, then we can create this. Which one is easy to see? These are easy to interpret, right? Previous one is for nominal data. Now let's see the graphical technique for interval data. Okay. Most part of your research is about the interval data. So this is very important. Interval data, graphical technique is very important. These are several graphical methods. There are several graphical methods that are used when the data is interval, numerical or non-categorical. Okay, interval data. The most important of these graphical methods is the histogram. So you should know how to create a histogram and how to interpret histogram too. The histogram is not only powerful graphical technique used to summarize interval data like before, but it is also used to help explain probability. So before applying probability, you have to first create interval data. Is also interval data, the graphical technique, histogram, is used to explain probability. Now let's see another example. Okay. Analysis of a long distance telephone bill. Following deregulation of telephone service, several new companies were created to compete in the business of providing long-distance telephone service. In almost all cases, these companies competed on price since the service each offered is similar. Pricing a service or a product in the face of stiff competition is very difficult. Factors to be considered include supply, demand, price, elasticity, and the action of a competitor. Long-distance package may employ per minute charge, a per month rate, or some combination of the two. Determining the appropriate rate structure is facilitated by acquiring information about the behavior of our customers, and in particular, the size of monthly long-distance bills. As part of a large study, a long-distance company wanted to acquire information about the monthly bills of new subscribers in the first month after signing with the company. The company's marketing manager conducted a survey over 200 new residential subscribes, wherein the first month's bills were recorded. So 200 new residential subscribes are you can see the sample. These data are stored in the file long distance. The general manager planned to present his finding to senior executives. Through histogram, what information can be extracted from this data using the histogram? So 200 new registered subscriber is a sample. This is sample. And we will see the data in here, but now we don't need to worry about. And from this data, we are going to draw histogram. Okay. So it's a what? Because we draw histogram, this is a what? You can infer that the data is a interval data. Okay. So from the using the histogram, the question is what information can be extracted from this data using histogram? Data is a monthly bill. So that data is what types of data? Think that. Data is interval data. In the previous example, we create a frequency distribution for 7 categories. In this example, we also create a frequency distribution by counting number of observation. Okay, but now the category is called different name. Okay, observation fall into series of interval. The category is called what? Class. So for interval data, we create histogram. Histogram is based on class. We have chosen 8 classes defined in such a way that each observation falls into one and only one class. These classes are defined as follows. So we have 1, 2, 3, 4, 5, 6, 7, 8 classes. First class is defined amount that are less than or equal to 15. Second class, amount that are more than 15 but less than or equal to 30, or something like that. This is a histogram. Based on the category before, class 15, 30, 45, 120, then you can see this is a category. So each category we count the frequency. Okay, then you can create this histogram. But this is for what? Interval data, not the nominal data. From the histogram, histogram of long distance bill, from the histogram we can interpret reality. About half, like 71, this is 71, 37, so 108 of the bills are small. That is less than $30. And there are few telephone bills in the middle range. And this one, 18, 28, 14, 60 divided by total 200, 30%. That is nearly a third of the phone bills are 90 or more. This slide shows how to create histogram. First, you should collect data. That's first job. Second job, create frequency distribution of the data. How? First, determine number of class to use. To determine number of class, we can refer to table 3.2, this one. Okay, approximate number of class in frequency distribution with the 200 observation. You can use this one, or you can use this one. We should have between 7 to 10. This is a number of class. This is number of observation. So number of observation is 200. So you have to see this one. So correspond to this one. So number of class is 7 to 9 or 9 to 10. So between 7 to 10, we can choose determine number of class. Or alternatively, we could use Sturge's formula. Number of class interval is 1 plus 3.3 times log n, log n, log n. If you use this one, it is a very similar number of 8. So you should know how to determine the number of a class. Previous slide we finish up to here. So we choose 8. Then determine how large to make each class. Class width, we call it class width. First, we calculate range. Okay, look at the range of data. That is, range is defined largest number minus smallest number. In our observation, largest number is 119.67 and smallest observation is 0. Okay, so range is 119.63. Then each class width becomes range divided by number of class. Okay, number of class is 8 in our example. Okay, range divided by number of class is 15. 15. That's why we have 8 class and class width is 15 in the previous example. Then finally we can create this histogram. Building a histogram. Frequency distribution of the long distance bill. Okay. How many class? 1, 2, 3, 4, 5, 6, 7, 8. And interval is 15. Class width is 15. Okay. Then I'll count our data here. Then frequency. Okay. 71, 37 from here. So all is 200. That's what frequency distribution. Okay. So based on this, we can create this histogram. From frequency distribution, we can create a histogram. Now, let's talk about Azibe, pronounced Azibe. This is called Azibe. Okay. Azibe is a graph of a cumulative frequency distribution. Cumulative frequency distribution. And we create Azibe in 3 steps. First, from the frequency distribution created earlier, calculate relative frequency. Relative frequency. And relative frequency is defined number of observation in a class divided by total number of observation. Okay. That's our first step. Okay, to create Azibe. Azibe is a graph of a cumulative frequency distribution. For example, we have 1 observation in our first class. Telephone bills from 0 to 15. Thus, the relative frequency for this class is 71 divided by 20. The total number of bills is 200, right? So we get 0.355. It is 35.5%. Okay. So what? From this is the class limit, and these numbers are frequency. Then divided by 200, then we get the relative frequency. This is a relative frequency. Then Azibe is graph over cumulative frequency distribution. Cumulative frequency distribution. Azibe is a graph over cumulative frequency distribution. We create an Azibe in 3 steps. Calculate frequency and calculate cumulative relative frequency by adding the current class's relative frequency to the previous class's cumulative relative frequency. For the first class, its cumulative relative frequency is just its relative frequency. So it is what? For the first class, its cumulative relative frequency is equal to its relative frequency. So this is the result. from the relative frequency, first class relative frequency is equal to cumulative relative frequency. Same. Second one, how do you get this? This plus this one. Okay. 0.355 plus, as you can see, this one, 0.540. Then last one is this one plus this. Okay, last class is previous plus this. Then you get the 1. So you know how to create a cumulative relative frequency. So to create a histogram frequency distribution, okay, to create algebra, you should create a relative frequency, then cumulative relative frequency, then you create graph. Then this is a algebra. Algebra is a graph of a cumulative frequency distribution. Calculate relative frequency first. Second, calculate cumulative relative frequency. Third, graph the cumulative relative frequency. Then this is a graph of a cumulative relative frequency, non-decreasing function, as you can see. X-axis is the amount of the telephone bill. Y-axis is a frequency. This is algebra can be used to answer question like this. Okay, so this is a useful one to this kind of question. What telephone bill's value? What telephone bill value is at the 50 percentile? So you see this one 50 percentile, and around 35 is 50 percentile. Okay, 50 percentile. It is a kind of central point. Okay. Let's summarize today's class. First, we run on this slide. We run types of data: interval data, nominal data, ordinal data. You have to remember the definition, and you should know how to explain that. And then we create graph and tabular table for nominal data. You should understand now. Just you should understand how to interpret. But when you meet offline, I will show you how to create them. The third one is a graphical technique for interval data. You should know how to create, and you should know how to interpret. But I'm going to explain how to create them when you meet offline too. And then we run algebra. Okay. Before finishing today's class, I'm going to show you next slide. Before finishing, we have homework. We have a 3-part homework exercise. So each exercise have 4 questions. So total we have 12 questions. Solve this problem and submit when you meet offline at the first time. Okay. And we'll have a more reference link. It's YouTube. So enjoy. Okay. Okay. Today's lecture is done. See you next time.